Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good evening, everyone. So today we are going to into a new chapter, which is chapter 7, Ionic Equilibria. But I was told by your tutorial lecturer that you have covered a bit of 7.1. So she asked me to enter the lecture straight into the buffer solution. So here I am. I'm going to cover the buffer solution in 7.1 acid and bases. And then we're going to cover a bit of 7.2. Okay, in a different video. Alright, so let's get started. Okay, so today we are going to learn about buffer solution. So there are two learning outcomes that we are going to cover in today's lecture. The first one, we are going to define buffer solution, and the second one, we are going to describe how a buffer solution control its pH. Okay, so buffer solution is a solution which has the ability to maintain its pH when a small amount of strong acid or strong base is added to the solution, which means that this buffer solution, if any cases that you put like a small amount of strong acid, or for example hydrochloric acid, or strong base, for example sodium hydroxide, into it, the pH will not change as much as you will expect it to be, because it can maintain its pH value as it is. Okay, alright. And this buffer solution is actually consist of weak acid and its salt, which means its conjugate base, or a weak acid, a weak base and its salt, or its conjugate base. So there are two types of buffer solution. The first one is acidic buffer solution, which consists of weak acid and conjugate base. And second one is basic buffer solution, which consists of weak base and its conjugate acid. So acidic buffer solution, it has pH less than 7, and the basic buffer solution has the pH of more than 7. Okay, so now let's get into it. So let's go into what is acidic buffer solution. So acidic buffer solution can be prepared by mixing a weak acid and its conjugate base. Okay, salt punya conjugate base. Okay, so contoh, we have our acetic acid here. Okay, or ethanoic acid, CH3COOH. Okay, so this acetic acid is a weak acid. So its conjugate base is a sodium ethanoate. So dia punya conjugate base dia adalah yang sodium ethanoate is a salt. So dia punya conjugate base is CH3COO minus. Tu conjugate base dia. Okay, since acetic acid is a weak acid, so the reaction that occurs for acetic acid will be this one. Okay, so acetic acid will be partially dissociated to form ethanoate ion CH3COO minus and hydrogen ion. Okay, sebabkan dia weak acid, so dia cuma partially dissociated. So maksudnya at the end of the dissociation process, there will still be a high concentration of acetic acid because of its partially dissociation only. Dia just partially dissociated, dia tak completely dissociated. So masih akan ada high concentration of acetic acid. Okay, however, its conjugate base CH3COO CH3COONA, sodium ethanoate, it is a strong conjugate base because weak acid will form a strong conjugate base and vice versa. Kalau weak base akan form strong conjugate acid. So bila dia strong conjugate base, dia boleh completely dissociated. Okay, so sodium ethanoate here will completely dissociated to form ethanoate ion CH3COO minus and sodium cation. Okay, alright. So actually, the amount of CH3COO minus or the amount of ethanoate and ion is actually mainly from the complete dissociation of sodium ethanoate. Okay, so dekat sini awak so here you can know that the buffer solution is actually consist of acetic acid CH3COO minus CH3COOH. Okay, sebabkan dia partially dissociated, so dia masih ada high concentration of it dalam buffer solution. And second one, they consist of ethanoate ion CH3COO minus because of the completely dissociation of sodium ethanoate. Okay, so ada dua komponen dalam acidic buffer solution. Okay, alright. So now kita nak tengok action of acidic buffer solution when we add a very small amount of acid into the buffer solution. So bila kita letak a small amount of acid in the buffer solution, the hydrogen ion will be consumed or will be reacted by the ethanoate ethanoate ion CH3COO minus. Sebab apa? Tadi Miss cakap acidic buffer solution consists of high concentration of acetic acid due to the partially dissociated of weak acid and ethanoate ion due to the complete dissociation of sodium ethanoate kan. So ada dua ni. So kalau asid dia letak dalam buffer solution, mestilah dia akan react dengan ethanoate ion sebab dia ada negative charge, ni ada positive charge, betul? So ethanoate ion will react with hydrogen ion from the acid to form acetic acid. Okay? So now as a result, there will be only a small change in pH. Sebab apa dia macam tak ada beza sangat pun bila you add acid tu. Sebab apa? Bila even though the concentration of CH3COO minus decreases, tapi concentration of acetic acid dia decreases, so the concentration of acetic acid akan increases balik. Okay, so dia macam tak ada very different change in pH pun. Sebab apa? Okay, bila dia dah consume H plus ni, dia akan form balik kat sini kan. So, macam tak ada beza. So that's why lah buffer solution ni boleh maintain its pH solution. Boleh faham ke? Okay, alright. So now kita tengok pula, kalau a small amount of base pula is added. So a small amount of base is OH minus kan. Okay, so bila ada small amount of base added inside the acidic buffer solution, time ni pula yang akan take action. So acetic acid, weak acetic acid will react with the OH minus to form ethanoate ion and water. Okay, so here acetic acid sekarang ni dia dah react dengan OH minus yang added tadi to form CH3COO minus and water. So as a result, there will be a small change in pH juga. Sebab apa? The added base yang di add tadi is now consumed by the ataupun react with the what we call it as weak acetic acid. So penambahan OH minus tak ada beza. Sebab apa? Dia akan react to form ethanoate ion pula. So sebab tu buffer solution can maintain its pH. Sebab bila dia tambah pun nanti dia akan kena consume dengan weak acid. Kan sama juga dengan tadi bila kita add contohnya HCl kan. Bila kita add strong acid tapi kena consume dengan ethanoate ion. So untuk form ethanoic acid balik, so macam tak ada beza. So macam kiranya dia tak ada perbezaan pH sangat lah. Ada sikit je tapi dia tak signifikan lah. So maksudnya dia still maintain its pH. So this is how acidic buffer solution react when there is a small acid or a small amount of acid or a small amount of base is added into the acidic buffer solution. Okay. So dekat sini you know, kita tengok dalam bentuk rajah. Okay, so you know buffer solution is made up of weak acid, contohnya acetic acid here, and its conjugate base of the salt, CH3COO minus ethanoate ion. So bila kita letak acid, yang akan reactnya adalah this guy. Okay, so this guy akan consume H plus yang ditambah tadi tu untuk form acetic acid balik. So pH tak beza sangat. Tak ada beza sangat. Okay, sekarang bila kita letak base pula, this guy pula yang This guy pula yang react untuk consume the added OH minus here untuk form balik ethanoate ion and water. So here we can say that that's why buffer solution can maintain its pH regardless of even though the small amount of strong acid and base is added into it. Okay, alright. So now we are going to look at the basic buffer solution. So in contrast with acidic buffer solution, for basic buffer solution, we prepare it by mixing a weak base and its salt. Okay, and its conjugate acid lah. Okay, so contohnya kita ada ammonia and ammonium chloride. So since ammonia is a weak base, so ammonium chloride is a strong conjugate acid, which means that the weak base will partially dissociated, okay, to form NH4 plus and OH minus. Okay, and since ammonium chloride is a strong conjugate acid, it will completely dissociated to form NH4 plus and Cl minus ion. Okay, so sama juga, since weak base NH3 can only partially dissociated, so it will have a high concentration. So at the end of the reaction pun, dia akan still ada high concentration of weak base because it only partially dissociated, and it will have a high concentration of NH4 plus cation because of the completely dissociation of ammonium chloride. So the amount of ammonium ion is mainly from the complete dissociation of ammonium chloride, and the amount of weak base NH3 is mainly from the partially dissociation of NH3. Okay? Alright. So now kita tengok kepada action of basic buffer solution. So sama juga, dia ada dua case lah dekat sini. Kalau kita add strong acid dengan kalau kita add strong base. So let's see. If we add a small amount of acid, okay, kita ada H plus ion kat sini, it will be consumed by a weak base to form NH plus cation. So dekat sini, pH dia takkan berubah sebab even though you add a small amount of strong acid, it will consume by the weak base to form a NH4 plus. So there is only a small change in pH. It's not really affected. Okay? Okay, next. Kalau kita letak small amount of base pula dalam buffer system tadi, so sekarang kita ada OH minus. So this OH minus tadi ni akan di remove ataupun react ataupun consume by the NH4 plus to form NH3. Okay, sebab apa? Dalam basic buffer solution ada NH3 dengan NH4 plus, betul tak? Okay, kalau tadi untuk hydrogen ion, untuk acid ni akan react, tapi untuk base ni akan react untuk consume the added OH minus ion from the base. So sekarang ni bila you add base, dia akan consume by the cation NH4 plus. So tak ada beza juga. As the result, there will be a very small change in pH, and the concentration of NH4 will decreases, and the concentration of NH3 will increases. Okay. So kalau soalan sudah terangkan about the action of basic buffer solution, this is how you can explain lah in terms of what species in the buffer solution will react with the acid or base, and then what happened to the concentration of the acid or base and dengan concentration of conjugate acid or base, and then you boleh bagi tahu how does it affect the pH in the buffer solution. Okay, that's how you can answer the question lah. Okay, so now kita nak pergi ke learning outcome seterusnya, iaitu kita nak write the Henderson-Hasselbalch equation untuk buffer solution and calculate the pH of buffer solution using the Henderson-Hasselbalch equation before and after the addition of strong acid or strong base. Okay, so basically this is the Henderson-Hasselbalch equation. So it says that pH is equals to pKa plus log conjugate base divided by weak acid. So ini untuk acidic buffer solution. So kita guna pKa lah kan, betul? and pH. Okay, so macam mana kita nak kira the pH of acidic buffer solution is, okay, so we know that the acetic acid here will partially dissociated to form ethanoate ion and hydrogen ion, and the sodium ethanoate will completely dissociated to form ethanoate ion and sodium cation. So sekarang ni kita boleh cari Ka untuk this what we call this reaction. So Ka dia adalah CH3, mana bullet saya. Okay, this one. For Ka untuk buffer solution ni ialah this one kan. CH3 product concentration of CH3COO minus times dengan concentration of H plus divide by concentration of acetic acid. Okay, so now you can find the what we call this concentration of H plus here by sebab dia akan bagi Ka punya value, so you kan boleh cari macam ni lah. Okay, so this is how you derive your Henderson-Hasselbalch equation actually. So bila you dah dapat concentration of H plus, you negatifkan log dekat dua-dua side. Okay, when you negative log dekat dua-dua side, you will get negative log H plus equals to negative log Ka minus log CH3COOH divide by CH3CO minus. Okay, so this one you want to cancel this negative log, right? So ini akan jadi pH, okay, equals to pKa, okay, and then you nak terbalikkan sebab you nak dapatkan plus dekat sini, so you terbalikkan dia, you akan dapat plus log ethanoate ion divided by acetic acid. That's why you boleh dapat this kind of Henderson-Hasselbalch equation. Okay, so you boleh cari pH menggunakan this equation. So this is actually shows how to derive Henderson-Hasselbalch equation. Okay, so kita guna Ka lah, Ka dengan untuk cari yang ini as a subject, and then you negative log dua-dua side untuk dapatkan this final product. Excuse me. Okay, now kita dah tahu apa Henderson-Hasselbalch equation. So sekarang ni kita nak tengok soalan pula, nak tengok contoh soalan and untuk solve this problem. So here we have 1 liter buffer solution is prepared by mixing 0.1 mole of acetic acid with 0.1 mole of sodium ethanoate. Okay, so kita boleh form buffer solution, okay, by weak acid and conjugate base. Okay, sekarang ni soalan pertama dia kata calculate the pH of the buffer solution. Okay, first kita kena so kita tahu volume dia 1 liter sebab dia dah siap-siap bagi tahu kita, right? Volume buffer solution tu memang 1 liter, and dia bagi tahu kita concentration for both acetic acid and sodium ethanoate are 0.1 molar. Okay, so now kita tahu the Henderson-Hasselbalch equation. To find the pH of buffer solution, we can use this Henderson-Hasselbalch equation. So pH equals to pKa plus log conjugate base divided by concentration of weak acid. So we know that, okay, since conjugate base is strong conjugate base, so kita boleh assume that sebabkan diorang ni completely dissociated to form CH3COO minus, so we can assume that the concentration of sodium ethanoate is equivalent to the concentration of ethanoate ion, which is equals to 0.1 molar. Okay, alright. So bila kita assume macam tu, kita boleh terus substitutekan value yang kita ada tadi. Dia bagi kita Ka punya value, dia bagi kita concentration punya value. So bila kita kira, kita boleh dapat pH equals to 4.74. Okay, so pH adalah 4.74. Okay, so that is how you find the buffer, the pH of the buffer solution. Okay, soalan sebelumnya dia kata, and then dia tanya, calculate. Mana saya punya ni? So tadi dia tanya, kita, oops, what happened? What happened? What happened? Apa yang saya tekan? Oh my god. What did I do? No. No. What did I do? Oh my god. Astaghfirullahaladzim. Look at your teacher. How come? Oh my god. Okay. Okay, now dia kata calculate the pH of the buffer solution after the addition of 0.02 mole HCl. Okay, and after the addition of 0.02 mole now. Okay, and dia kata kat sini kita boleh assume, we can assume that the volume of the solution does not change when HCl or now is added. Okay, so dia bagi, so kita boleh kira. Okay, so now kita nak kira. So kita tahu buffer action kita kat sini disebabkan acidic buffer kita. Okay, so buffer solution consist of acetic acid dengan ethanoate ion. So bila hydrogen ion masuk, yang akan react adalah ethanoate ion. So that's why kita kata kat sini buffer action punya equation adalah ethanoate ion react with the added H plus to form acetic acid. Okay, so this is the first one. You have to do it. Okay, so dekat dalam for this buffer calculation, bukan guna I table tapi ICF table. Okay, and dia boleh dalam bentuk concentration and number of mole. Okay, bila masa kita nak guna concentration, bila masa kita nak guna mole. Okay, kalau soalan tu dia bagi kita, dia dah tulis kat situ. Okay, memang dia assume yang kalau tambah acid dengan base, tak akan ada berlaku perubahan volume. So, that's why kita boleh guna concentration dalam ICF table, initial change dengan final table. However, kalau soalan tu tak tulis yang assumption yang kalau add acid dengan base, volume tak berubah. Kalau tak ada benda tu, contohnya macam soalan tutorial kita, dia tak cakap pasal assumption tu. So, kita kena guna ICF table in mole. So, maksudnya you have to find the number of mole of the species lah, of the reacting species. Okay, tapi here untuk case yang ini disebabkan dia dah bagi tahu siap-siap assumption dia volume is not change if you add the HCl, so you can use the ICF table in concentration ataupun molarity punya format. Okay, so in this case initially your ethanoate ion has 0.1 molar and we add here 0.02 molar of HCl kan. So maksudnya H plus kita adalah 0.02 molar. Okay, and then it will react to form acetic acid. So acetic acid kita pada mulanya memang ada 0.1 sebab ni dalam buffer solution kan. Okay, dalam buffer solution kan. So memang asalnya acetic acid kita ada 0.1 kan molar, betul tak? Okay, so sekarang ni lepas reaction berlaku akan perubahan lah kat sini. Okay, apa perubahannya? Sekarang ni ethanoate ion ni akan react dengan H+. So macam ni nak tahu berapa kita kena tolak. Okay, kita tengoklah siapa yang paling sikit kat sini. Yang paling sikit kat sini adalah 0.02 ni kan. Maksudnya ini macam dia punya limiting reactant. Okay, so kat sini kita akan tolak dengan 0.02. Dekat sini pun tolak dengan 0.02. Tapi dekat belah produk ni tambah dengan 0.02 molar. Okay, so dekat sini final change dia untuk ethanoate ion punya concentration jadi 0.08, hydrogen jadi 0 and acetic acid jadi 0.12 molar. So dekat sini you can see that when acid is added into the acidic buffer solution, the concentration of ethanoate ion decreases and the concentration of the acetic acid increases. Okay, So, kita nak kira pH yang baru selepas dah ditambah HCl. So, kita kena guna concentration yang dekat final ni. Okey, katakanlah awak guna ICF table dalam bentuk mol. You have to find the molarity first, baru you boleh cari pH. Okey, tapi disebabkan kita guna ICF table in terms of concentration, so boleh terus dia masukkan kita punya data dalam kita punya Henderson-Hasselbalch equation. So, dekat sini kita boleh dapat pH equals to negative log 1.8 times negative 5 plus log 0.08 divide by 0.12. Sebab ni weak acid, ni conjugate base, betul? So, you can get pH is equals to 4.57. See, dia macam tak ada effect sangat pun. Tadi sebelum add acid, 4.74. Sekarang lepas add acid, 4.57. Dia tak bagi significant change pun dalam pH. Okay. Now, kita tengok what happen kalau kita add now. Okay, kalau kita add strong base, okay. Yang akan react dia adalah, yang akan consume hydroxide ion from now adalah acetic acid. So, acetic acid react with hydroxide ion from now to form ethanoate ion and water. So, water ni tak perlulah kita buat dia punya ni kan. Okay, so dekat sini, initially, acetic acid ada 0.1 and then you add hydroxide ion 0.02 and then the initial ethanoate ion is 0.1. Okay, and then change dekat sini bila this one react dengan hydroxide ion. So hydroxide ion kat sini as limiting reactant. So kita kena tolak 0.02. Ni pun tolak 0.02 tapi dekat produk sini tambah 0.02. So you will get the final concentration is 0.08 for acetic acid and 0.12 for ethanoate ion. So kat sini kosong lah, so dah habis consume all. Okay, so dekat sini you can find the pH directly sebab table ni dalam bentuk molarity. Okay, so you boleh cari pH dia kat sini 4.92. Okay, just substitute everything, every values that you got from the final punya concentration ni dalam Henderson-Hasselbalch equation. Okay, remember, okay, ini you boleh guna ICF table in terms of concentration kalau dia bagi assumption dia volume dia remain unchanged kalau add acid dengan base pun. Tapi kalau soalan dia tak tulis pun pasal assumption volume is not changed kalau acid dengan base tu ditambah, awak kena buat ICF table in terms of number of mole. Maksudnya awak kena tukar, awak kena check number of mole and then dekat final ni tadi you dapat mole in terms of number of mole kan. So you kena cari in terms of concentration baru boleh masukkan dalam equation Henderson-Hasselbalch ni untuk dapatkan pH. Okay, remember that. Okay. Okay, now kita nak tengok kalau untuk nak cari pH of buffer solution pula. So, sama juga dia tunjukkan how to derive the Henderson-Hasselbalch for this basic buffer solution. So, kalau tadi nak derive acidic buffer solution guna Ka, tapi kalau nak derive basic buffer solution guna Kb. So, kita derive, kita akan dapat this Henderson-Hasselbalch equation for you to find the pOH. So, ini untuk kira pOH kan? Untuk basic buffer solution. Tapi kalau dia suruh cari find pH of basic buffer solution. Tapi miss, kita boleh kira kita boleh kira pOH je kan? So, pernah nampak tak ni? pH plus pOH equals to 14. Okay, so you can use this equation untuk dapatkan pH. So, you dah tahu pOH dia based on this. So, you boleh kira pH 14 tolak dengan pOH. Dapatlah pH dia sekian. Okay, alright. Kita cuba buat soalan ni. Okay, soalan dia beza sikit kali ni. Sekarang ni dia kata, a buffer solution is prepared by mixing 400 ml of 1.0 molar of ammonium chloride with 300 ml of 0.1 molar of ammonia. So, dia suruh kita calculate the pH of the buffer solution. Okay, kalau tadi soalan dia dah bagi siap-siap dah. Oh, volume buffer solution tu memang 1 liter, memang dia dah bagi asing-asing dah. So, maksudnya kita tak perlu, maksudnya dia punya concentration tu memang tu lah 0.1 molar. Tapi sekarang ni, okay, sekarang ni dia berbeza sikit. Kenapa dia berbeza? Sebab dia tak bagi molarity untuk total volume buffer solution tu. Dia bagi molarity untuk berapa jumlah acid dengan conjugate acid dengan base yang dia mix tu. So sebab tu kita kena kira balik semula a new molarity of the buffer solution. Macam mana? Okay, kita mula-mula kita cari total volume. So total volume of buffer solution here is 400 ml plus 600 ml. So we got 1000 ml or equals to 1 liter. Okay, lepas kita dapat total volume, kita nak kira mole of ammonium chloride kalau dia dekat dalam 1 liter mole of ammonium chloride dalam kepekatan 1.5 molarity and volume 400 ml. So kita dapatlah mole dia 0.6 mole. Okay, and then kita kira mole of NH2 dapat 0.06 mole. Okay, lepas kita dapat mole, so kita nak cari new concentration of ammonium chloride dengan ammonia in the new total volume of buffer solution, okay, which is 1 liter. So kita boleh cari concentration of ammonium chloride now is 0.6 molar and the concentration of ammonia now is 0.06 molar. Okay, sebab apa kita kena cari molarity yang baru? Sebab volume dia bagi tu bukan total volume buffer solution. Volume yang dia bagi tu, concentration dia bagi tu bukan concentration bagi volume keseluruhan total buffer solution. Volume yang dibagi tadi tu hanya untuk that species, that ammonium chloride and that ammonia. So macam dia bukan kepekatan untuk total volume of buffer solution 1000 ml tu. So kita kena cari yang baru. Okay, so macam ni nak cari yang baru, kita kena cari mole dulu. Lepas cari mole, baru kita cari dia punya new concentration. Sebab apa? Dia punya mole dia akan sama. Maksudnya dia punya total amount of molecule dia sama. Yang beza dia kepekatan dia. Sebab apa? Sekarang volume dah bertambah. Kan, betul tak? Sebab kita dah campur dengan kita dah campur dua acid dengan base kan, yang berbeza. So volume dah lain. Okay, so now bila kita dah dapat new concentration of NH4 dengan ammonium chloride dengan ammonia yang baru dalam buffer solution, kita bolehlah cari pOH kita. Okay, so kita boleh cari pOH kita menggunakan Henderson-Hasselbalch equation. Masukkan yang baru punya value. So kita boleh dapat pOH kita 5.74. Okay, tapi itu pOH. So kita kena cari pH. Cari pH kita guna konsep pH equals to 14 minus pOH. So dapatlah kita punya pH 8.26. Okay, so this is the pH of the basic buffer solution before the addition of strong acid and strong base. Okay, so sekarang ni bila kita add pula, okay, dalam buffer tadi kita ada weak acid NH3 dengan conjugate weak base NH3 and conjugate acid NH4+. Okay, bila now added, kita ada OH minus, betul? So yang mana yang akan react? Yang ini. So ammonium and ion kita akan react with OH minus to form NH3 and water. So kita akan buat ICF table in terms of molarity. Sebab tadi soalan tu dia cakap dia bagi assumption volume kalau lepas add acid dengan base tak berubah kan. So kita boleh guna molarity punya ICF table. So kita tengok kat sini, asalnya initial ammonium ada 0.6 molar, hydroxide ion ada 0.15 molar, and then asalnya NH3 ada 0.06 molar. Okay, lepas NH4 react dengan OH minus, dia akan tolak dengan 0.15. Okay, and then ammonia akan tambah 0.15 kan. So dia gain lah, betul tak? So final molarity dia lepas the reaction is the concentration of NH4 decreases sebab dia dah consume OH minus tadi kan, dia dah react dengan OH minus, so dia dah decreases. And concentration of OH minus dah tak ada, kosong, dah fully reacted by the NH4 plus, and then NH3 punya concentration akan increases. Okay, so now we can find the pOH by substitute all the values from the final punya concentration into the Henderson-Hasselbalch equation to find the pH of 5 point, to find the pOH sebab ni base kan, of 5.08. So you can find the pH by minus the 14 minus dengan pOH, you will get the pH is 8.92. Okay, so sekarang ni bila HCl pula yang added, yang akan react adalah weak base NH3. So yang akan react NH3 akan react with acid to form NH4+. So kita akan buat ICF table lagi sekali. Bila kita buat ICF table, kita akan dapat final concentration dia adalah concentration of NH3 decreases sebab dia dah consume H+, and the concentration of NH4+ increases sebab dia dah deformed by the reaction of NH3 dengan acid tadi. So you can find the pOH, substitute the value that you got from the final concentration to get the pOH is equals to 5.84. But you need to find pH. So 14 minus pOH, you will get pH 8.16. So that is how you answer this kind of buffer solution guna ICF. Lagi sekali Miss ingatkan, kalau guna ICF, Miss lagi galakkan you guna in terms of mole lah. Tapi kalau soalan tu memang dah bagi siap-siap yang volume is not change, even though you add strong acid dengan strong base, you boleh guna ICF in terms of concentration. Tapi kalau kalau soalan tak cakap apa-apa, better guna in terms of molarity, in terms of number of mole. Sebab apa? Possible dia punya concentration dah berubah lepas you add acid. Okay, so bear that in your mind lah. Okay, so yeah. This one you can try answer this. Okay, masa tutorial ke boleh buat. Okay, ataupun sebelum PSPM nanti you try buat lah soalan ni. Okay, so that you can understand more about this calculation of 4 buffer solution. Okay, so we will continue in the next video untuk titration, acid-base titration. Okay, so that is all for now. Okay, I hope that you can understand this video. Okay, yeah. Thank you for watching. Bye. Assalamualaikum.